This is lesson 1.5. We're going to talk about measuring angles. So just a little refresher from our last lesson. Parallel lines are lines that never intersect. The symbol for parallel looks like a set of parallel lines, and the markings on lines that are parallel are little triangle symbol, arrow symbol things like this and this. And for perpendicular lines were lines that intersected to form a right angle. So we would see the right angle on them when we draw it. And the symbol for perpendicular is this, an upside down T. So for example 1, it says draw quadrilateral ABCD. They tell us that segment AB is perpendicular to segment BC, angle A is congruent to angle C, and segment AB is congruent to segment BC. So I know I'm going to have a right angle somewhere, so I'm going to draw two that meet at a right angle. They meet at B, so B is going to be the point where I put at the intersection, and then one side could be A, one side could be C, right? A, C, so that's segment AB, segment BC, with the right angle at B. And they also tell me that segment AB and segment BC are congruent, so I'm going to mark them with the dashes for congruency. We also know that there's going to be a point D somewhere else, right? A, B, C, D, so D's got to be somewhere else. And however we draw this, we're going to mark that angle A and angle C are congruent to each other. So we're going to put the curves inside the corners for angles A and C. So there's one here for you to try. You can pause. The answers are posted in the blank notes on Google Classroom. Some more terminology to know. So we're going to measure angles. We know angles are measured in degrees, and they can be classified depending on their measure. So if they're less than 90 degrees, they're acute. If they're greater than 90 degrees, they're obtuse. If they're equal to 90 degrees, they're right. And if they're equal to 180 degrees, they're straight. So in example 2, we're going to use this protractor to measure each of these angles. Well, let's see the whole picture because we're missing one of the angles. And then we're going to identify any that are congruent and mark them in the diagram. So when I'm doing work with a protractor, there's numbers on the outside and there's also numbers on the inside, right? Going 0 to 180 one way, going 0 to 180 the other way. Whatever you do, stick with the same set of numbers. So I'm going to stick with all the outside numbers here. And what I'm going to do is I'm going to write the number that each letter passed through. So X passed through the 0 on the outside, Y passed through the 40, V passed through the 90, W passed exactly between 130 and 140, so that's 135, and Z was at 180. And I kept all the outside numbers. To measure an angle, we're just going to find the difference between whatever two numbers it found. And we always want the positive answer, so bigger minus smaller. So for YOW, we're going to find the difference between 135 and 40. So that would be 95 degrees. And that, because it's bigger than 90, would be an obtuse angle. They're not asking us to classify them, but it's always good to know. XOY, so XOY, difference between 40 and 0 is 40. That would be an acute angle. For VOW, difference between 135 and 90 is 45 degrees, another acute angle. Angle WOZ, difference between 135 and 180, would also be 45 degrees. So we do have a pair of congruent angles because these angles that have the same measure would then be congruent. So that was VOW and WOZ would be congruent to each other in this picture. And our last one is YOZ, so that's this bigger one. The difference between 40 and 180 would be 140 degrees, and that would be another obtuse angle. Just like we had the segment addition postulate, we have the angle addition postulate, which I'm going to look at here. It's basically that the sum of the two smaller adjacent angles, adjacent meaning next to each other, sharing a side and a vertex, is equal to the measure of the whole angle. So this piece here plus this piece here equals the whole entire thing. So we did the same thing with segments, and making that equation is called the angle addition postulate now. So we're just going to find some indicated angle measures in this picture. So the first one they're asking for is DAE. So if I traced DAE, the corner that's pointing to is here. So that would be 62 degrees. For AEB, the corner it's pointing to is here. So that would be my 117 degrees. Now I'm not putting these marks for congruency, I'm just putting to show which angle we're talking about. For E, B, C, so that was this corner over here, so that was 55 degrees. And then for B, C, D. So now notice this has both of these in the corner, right? It's both of these together. So I'm going to add them up. 36 plus 62 gives me 98. So BCD is actually 98 degrees using the angle addition postulate. In the one that you're going to try, you want to name an angle that has this indicated measure. Some of them have multiple answers. Some of them only have one based on what's drawn for us in the picture. And you may have to combine some to find one that would equal, let's say, 82 degrees. So go ahead, give that a try. You can pause. The answers are posted in the blank notes on Google Classroom. So let's use the angle addition postulate here. We know that the whole thing, LKN, the whole thing is 145 degrees. So if I add the two smaller pieces together, that should equal 145. So that's going to be 2x plus 10 plus 4x minus 3 equals the whole thing of 145. So I'm going to combine my like terms. We're going to get 6x plus 7 equals 145. Take away that 7, 6x is 138, and divide by 6, x is equal to 23. So if x equals 23, they want us to find the measure of angle MKN. MKN was here. So we're going to plug it into 4x minus 3. So it's going to be 4 times 23 minus 3. So 92 minus 3 is 89 degrees. Something I should mention that I haven't said yet, when you're talking about the measure, the number of degrees an angle is, we put a little m out front to say that it's the measure. When I talk about angles that are congruent, they no longer get the angle symbol on them, right? So when I'm just talking about angles, like I was talking about, here, if P is in the interior of angle RST. So when you're talking about the actual angle, no M, but when you want to talk about their measures and put it into an equation with an equal sign, then they get the M on them. All right, so that's true here as well. So here's a try for you to do. You can pause. The answers are on Google Classroom. In example 5, we see a word that we saw in our last lesson, the word bisects. So remember that bisects means to cut into exactly two identical congruent pieces. So they're telling me that BD, ray BD, bisects angle ABC, then the two small angles inside are congruent, and that means their measures are equal. So I could say that 3x plus 6 is equal to 7x minus 18. Those two angles are identical. So minus 3x, we get 4x, add the 18, we get 24. And when I divide, x is 6. So if I want to find the measure of angle ABC, ABC is now the whole thing. So I could either find one and double it or find both and add them up, right? If it's bisecting, they should be the same. So 3 times 6 plus 6, 18 plus 6 is 24. Or if I put it in here, 7 times 6 minus 18, 42 minus 18 is 24. So altogether, the measure of angle ABC is 48 degrees. There's one here for you to try. You can pause. The answers are posted in Google Classroom. In example 6, they're giving us a description that we're going to have to draw out to solve. So ray SA bisects angle RST. So I know I'm going to have an angle RST. I'm going to draw it nice and big so I have room to do things inside. It will not be drawn to scale. So R, S in the middle, it's the vertex, T. And SA, so SA bisects it. So this line inside makes two identical angles. They also tell us that B, point B, is in the interior of angle AST. So inside AST, inside this angle here, I have a point named B, which creates ray SB. Additionally, the measure of angle ASB is 11 degrees, and the measure of angle BST is 25 degrees. We want to find the measure of angle RST. It's a whole big thing. So we need to find RSA to do that. RSA is congruent to AST, right? They were congruent to each other because it got bisected. So whatever the measure of angle AST is, that'll match with RSA. So AST, if I add together the 11 and the 25, is 36 degrees, meaning this angle is also 36 degrees. So the entirety of measure of angle RST would be 72 degrees. The final one you're going to try does not have bisect, but we do have some interiors. So it's going to look more like example 4 and try 4 once you have it drawn. But that's it for our lesson on measuring angles.